Welcome to my review of objects for Java. There's a whole lot to know about objects in Java because Java is famous for being an object-oriented programming language. I'm not going to review everything. I'll have a series of short videos that add on to each other. In this video, I'll just introduce what's the idea of an object, how does it differ from a primitive data type, and how do you use objects, how do you create them, and how do you use them. In the next video, I'll show you how you can create your own types of objects by declaring your own classes that are sort of like blueprints that you can use for defining what your own objects are going to be like. And then in the third video, I'll show you some more complex examples of that and show you the range of things that you can do with objects. So let's start out this way. Here I have declared an int called n to be this number. So int is a primitive data type. You can recognize primitive data types because my IDE has highlighted it here in purple. It also starts with a lowercase I. All primitive data types start with lowercase letters. There's a couple things that make primitive types different than objects. But one of the major ways they differ is a primitive data type, when you declare it, the Java virtual machine sets aside a fixed amount of memory that's large enough to hold the range of values that that data type is supposed to hold. So when I declare int n, it's set aside a certain amount of memory, and if I try and store a number that's too large, it says the literal of type int is out of range. And what that means is that the amount of memory required to hold this number is larger than the amount of memory that's been set aside for an int. There's no way to tell it to set aside more memory so that you can hold a larger int. That's just it. There is a primitive type called long, which sets aside more memory per variable, and it can hold larger values. It still thinks this is an int. See how it says of type int? Even though it's getting assigned to a long variable. So I have to have some way of marking this explicitly as being the long data type, and you can do that by putting a capital L at the end of it. And now you see it's gone back to being okay, and I can run it, and that's just fine. But if I add more digits, now it's out of range of long as well. And now we're kind of stuck, because there isn't a data type that holds an integer that can hold one that's that large. So I'm going to introduce you to a special kind of object called a big integer. Let's make it. So I'll say big integer m. Notice that the syntax is exactly the same as creating any other variable. So here I have data type followed by variable name. Here big integer is my data type. M is my variable name. Right now it's complaining. It says big integer cannot be resolved to a type. I'll say import big integer from java.math. So I can't just assign it a value like this. And the reason why is, here I'm going to go ahead and get rid of long. The reason why is because when you have objects, you have to run a special command that will build your object specially. That command is a method called the constructor for that object. So the constructor for an object is the same name as the object, the type of object itself. So here I would say new big integer. And I'm going to give it an input that is a string representing the number I want it to be. This pattern will always be the same for creating all objects. You declare a variable that could hold your object this way. You say big integer is the data type, and that's the variable name. And you can do that on its own line if you want to. Just declaring it doesn't actually initialize it to a value. Right now, m actually points to a special value called null. We can talk about that later. This part that I've highlighted here, the new keyword followed by the big integer constructor, will create a new big integer object for you and assign it to the variable m. So below this line, m now contains an object. And if I want to, I can just put it in a print line statement, and there you see I've displayed it. Okay, what's special about objects is that objects can run methods for you. They have built-in behaviors. So, for example, let's do this. So the way that you tell an object to do something for you is you start with the variable name holding the object, and then you put a dot, and you see it's popped open a box, and these are all of the methods that that object can run for you. These are all the behaviors that it has. So I'm going to scroll down the list here to where it says POW, and I'm going to put 2. What this does is it takes the number represented by m and it raises it to the power of 2 in this case. It actually returns the answer rather than modifying this number. So I'm going to create a new big integer called result, and I'm going to assign it the output from raising m to the second power. So now I can say, let's do this, m squared equals, and then I'll display result. And you see that this very big number squared equals this even bigger number squared. Big integer is kind of cool because it has no limit. Well, its limit is the amount of memory that you have available to Java, but you can fill your entire memory available to Java with one very large number if you want to. I can just keep making this number bigger and bigger, and big integer is going to do the right thing without complaining. So you can see here we've got a really big squared number. The point about objects, though, is that objects run a whole lot of methods for you, and that the pattern for doing that is m dot something.